Alright, this is free response 1989 AB4. So let's go ahead and take a look at the problem. It says let f be the function given by f of x is equal to x over x squared minus 4. And in part A it says find the domain of f. So I'm going to look at the function, and domain refers to the allowable x values, what's allowed for x. But when I look at this, I notice that I have a fraction and a square root. So when I think about what's allowed for x, well, I don't want there to be a 0 in the denominator, and I want what's underneath the square root to be positive. So I'm going to take x squared minus 4, and I'm going to say I don't want it to equal 0, but I want it to be positive, so I'm going to say it's greater than 0. And I'll go ahead and solve, so I can add 4 to both sides, so I'm going to have x squared is greater than 4. Then I'll take the square root of both sides, which will give me the square root of x squared. Since I don't know what x is, I have the absolute value of x, okay, is greater than 2. So we know there's two solutions here. Since it's greater than, we're going to have a positive case, because remember, if you think about absolute value of x, it is a piecewise function, okay. For the positive piece, when x is positive, that would occur when x is bigger than 0. So then absolute values, you can usually include the equal to on the 0. But when x is positive, we just take positive x. When x is negative, really what's happening is the absolute value is doing the opposite of x when x is negative, and that's when x is less than 0. So that's what it means for it to be a piecewise function. So I'm going to have positive x greater than 2, and it's a greater, so I'm going to have an or. And then since the negative case, I'm going to have negative x is greater than 2, but usually what we do is we'll just go ahead and divide by the negative and flip the inequality sign around for our piecewise. So our domain then is the set of all numbers x such that those colons mean such that x is greater than 2 or x is less than negative 2. So there's your domain. And the good news is on domain you don't have to write it using that notation. It's entirely up to you if you want to use that notation. So there's that first part. Part B, while I'm erasing this, Part B talks about finding the equation for a vertical asymptote. Well, vertical asymptotes is when only the denominator equals 0. So I'm just going to look at the denominator. This fraction doesn't simplify, so there's nothing that cancels. So I'll come up here and put Part B. So I'm just going to think about when the square root of x squared minus 4 equals 0. I can go ahead and square both sides. Okay. If I square both sides, that'll get rid of the square root, so I get x squared minus 4 equals 0. I solve that. Real quick, add 4. And I'll have x squared equals 4. Take the square root of both sides, and you'll have, again, absolute value of x is equal to 2, which gives you two solutions, plus or minus 2. Okay, so your vertical asymptotes, your VAs, your vertical asymptotes would occur when x is equal to plus or minus 2. Positive and negative 2. Part C, write the horizontal asymptotes. Well, when you do horizontal asymptotes, you need to think about what's happening at the tails, or the end behavior. So what I'm going to do is I'm going to take the limit as x approaches infinity of x over the square root of x squared minus 4. Now, since we're doing the limit as x approaches infinity, I can do my shortcut. So I'm going to go limit as x approaches infinity of x, the largest power on top is x, the largest power on bottom would be the square root of x squared, which ends up being the limit as x approaches infinity of x over the absolute value of x. Now, remember we said this was piecewise, and since x is going to positive infinity, we'll use the positive piece for x, so we'll just have x over x. So we're going to have the limit as x approaches infinity of x over x, which just ends up being 1, because it ends up canceling and it's the ratio of the coefficients, so that first limit's 1. Now when you do the left end behavior, since there's two ends to every graph, there's a possibility of there being two different asymptotes. So it's gonna be the same steps here. This first step right here will end up being the same as the second step, and then when we get down to the third step, here's where the difference is going to be. So I'll just go ahead and write that. When you have x over the absolute value of x, we know that we're going to negative infinity, so we'll take negative x this time. So we're going to have the limit as x approaches negative infinity of x over negative x, And again, those will cancel, and it's the ratio of the coefficients, which is -1. So our horizontal asymptotes, our HA, would be y equals plus or minus 1. And those would be the two horizontal asymptotes. So we have our VAs, we have a horizontal asymptote, we know what the domain is. Okay, so now we can look at part D. And part D says find the derivative. So I'm going to go on to a new slide to do part D. So we have, so let me go ahead and click to the next slide. Add a slide here. Let me see. Let me add one real quick. So then we take for part D, we have the equation was f of x was equal to x over the square root of x squared minus 4, and they want us to find the derivative. So this is just going to be quotient rule. So derivative f prime of x, the derivative of the top would be 1 times the bottom, which is going to be x squared minus 4 to the 1/2. Okay, so far so good. Quotient rule says minus. Then the derivative of the bottom would be 1/2 times x squared minus 4 to the -1/2. That's the power evaluated at the inside times the derivative of the inside, which is 2x, and then times the top, which is x, over the bottom squared. Now, when you square the bottom here, you're going to just get rid of the square root. So we're just going to have x squared minus 4. Then on top, we can factor and simplify a little bit. I can do some simplifying here. This 2 and this 2 is going to cancel, so I can go ahead and do that. That 2 cancels. So then I factor, and I can see here that I've got an x squared minus 4 and an x squared minus 4 in common. I'm going to take the one with the smallest exponent. So I'm going to have x squared minus 4 to the -1/2, and I'm going to factor that out. So when I take this and divide it by this, I'm going to take that and divide it by that, because I take this whole expression and divide it by this, I'm going to have to subtract the exponents. So I'm going to end up with x squared minus 4 to the first power. So I can drop the parentheses in that first part here. Okay, so I can just say it's x squared minus 4 to the first, because 1/2 minus a -1/2 is 1/2 plus 1/2, which is 1. Then we'll go to the next part. We're going to have a minus. So it ends up being, when I take that part here, and this, the 2's already canceled, so we're going to have this x squared, so we can go ahead and put that down. So we're going to have minus x squared. Okay? And then times this, so all of this is getting divided by this. Well, this now is just going to cancel, so I'm just going to cancel that part. So we're just left with the x squared. All over the x squared minus 4. Now that x squared minus 4, remember, in the bottom is to the first power. So now I'm going to take this and I'm going to bring it to the bottom and add those exponents. So we're going to have f prime of x is going to be equal to, the bottom be x squared minus 4 to the 3/2 power. And then on top I'm going to have x squared minus x squared cancel, and we have -4. And there's our derivative. So that's part D.